Well, thank you all for having me here today. I would like to tell you about, it's not working. Okay, next one. 7 misconceptions that we meet quite frequently about vertical farming and how we have dealt with them so far. The first of these misconceptions is that we must make plants adapt to nature. And that's not true, because plants don't like nature at all. If you have a look at plants in nature, and even in the best circumstance with the ideal leaf canopy, out of the light that they are getting from the sunlight, they're only to transform 9% into assimilates. And what we do at PlantLab is we have a very close look at how plants behave. And this is all common knowledge for you, but I just walked through it not to skip anything. This is a chloroplast, and the chloroplast and leaves, they absorb light, but they absorb only the red and the blue, and they reflect in white light the green. That's why they are green to us. So in PlantLab circumstances, we only give red and blue and a little far red. And you might think that light is the most important asset for plants, but at least as important are these other things. It's the water and the nutrients that they take up. It's the exchange of gases, and it's the transportation of assimilates from the chloroplasts towards the sinks, the fruits. And it's this whole field of micrologistics in combination with light that is what we try to optimize in our company. It's very simple. We say it's a balance act between light, carbon dioxide, water, nutrients, and leaves on one hand side, and maintenance, sinks, and temperature, which equals speed on the other side. And back in 1989, we started studying crops and making mathematical models. And these models are actually our daily tool to understand plants better and better, also in this controlled environment. So in short, what did we do? We started thinking differently in 1989. We started making mathematical models for 10 years. Then in 2005, we made plans for producing in a totally different environment, and we were able to build this pilot in 2006. In 2008, we patented some of our knowledge. In 2009, we started building our research center. In 2010, we built 2 larger prototypes, and the largest one is 100 square meter in 2 levels. In 2011, we have engineered the larger plant production units, as we call them. And today we are pretty much ready to go to the market. So it's quite a road that we have been through. The second misconception is that this is paradise for plants. Well, that's not true. This might be paradise for us, but it certainly is not for plants. If plants would rule the world would look like this. And this is what we did actually to make them extremely happy. We created Plant Paradise, and this is the picture of the 2-layer prototype plant production unit that we have up and running now for 2.5 years. This is the bigger picture. This is a plant production unit, and our unit is built up out of modules of 40 times 8 meters. It can be smaller, a module can't be bigger. That has to do with the equality of transportation of the air. And in such a unit, we are able to produce at least 200 grams of fresh vegetables and fruits every day. So if a person would need 200 grams, it would only take 1 square meter per person. So to feed 100,000 citizens, it would take a unit of 100 times 100 meters in 10 layers. And that's a very compact way of producing. The advantages of growing in a vertical farm, they have been mentioned quite some times today, but I want to just repeat them. This way of growing is very secure and safe. And without changing anything about the genetics, we are able to improve the beautiness, the taste, and the nutrient content of the products. We can make them taste much better, and we have much higher yields than we were used to in greenhouses. And as been said today before, we save at least 90% on the water use. And since we have built our pilot first in 2006, we never had to use any pesticides. We never have any pests and diseases. We don't use overpressure. We don't wear protecting clothes. We just walk in and out, and still in plant paradise, plants seem to be not susceptible for pests and diseases, and that's really a gift. So the third misconception has been solved for that as well. Growing in a vertical farm doesn't need a lot of water and pesticides. In our situation so far, we never had to use any pesticides. What we have done in 2009 is we have built this research station, and we have built it on the University of Applied Sciences in Holland in 's-Hertogenbosch. And we work closely together with teachers and students. That's what we want to do. We want to exchange that information. And in this research center, we can control the 3 colors of LED light that we use. We can give different sorts of energy, infrared, temperature, root temperature, and we can play with all these parameters. And we do that in order to make what we call a plant identity, a plant ID of each and every crop that we start with. So we have a plant identity for lettuce, and we have them for herbs, and we have them for fruit-bearing vegetables. And the plant identity is like we place this plant on a test facility, and we ask this plant, what kind of a plant are you? Are you a racing car? Are you a car? Are you a truck? Are you a motorcycle? We have to know what you are. And once we have found out what type of plant that you are, we start making growing recipes. And the growing recipe is a totally automized recipe that ends up exactly with the product that you want to produce. And in the metaphor, it's like sat-nav, where our system says, we will bring you there safely as long as you don't touch the steering wheel. We do this totally automatically. So in the nearby future, we'll have different plant production units in different places. And we can control them all from what we call use and control. And we can control them because there is our operating system inside, and we can constantly upload our growing recipes. Well, growing recipes, they look like this. This is basil. It's the same basil 10 times grown with 10 different recipes. I'm not saying one is better than the other. It only proves that we could grow the first one wherever at the world, year around, or the last one. These are 10 totally replicable growing recipes. And we have been working with about 40 different crops so far, and this is just an example of what we have been doing. So today we have heard a lot about lettuce and herbs. That's where we started as well. But we are able to grow squash, tomatoes, even potted roses, strawberries. Actually, there is no reason why we couldn't grow any crop. This is a picture of the plant production unit that we have built in March 2010. It's a 2-layer system. This is one of the layers. This is a potted plant called Fittonia. And we are growing these plants at a light level that is far below the light compensation point. So I think we are there at maybe 10 or 20 micromoles, still exceeding the production level of the greenhouse. So this is the picture where you see the 2 levels. And of course, this is the example. And here you see the 2 layers with a very low light intensity. But that light intensity is different for every crop. The 4th misconception is that food should grow where nature is kind to it and then be transported to where we live. That's a really outdated system, we think. So this traditional supply chain is very long. It's taking food from the other side of the world to this place today. And most importantly, you see, in the end, we seem to lose about 50% of what we produce. That's pretty much ridiculous. So we are looking for a new supply chain, an ultra-short supply chain where you grow your food right around the corner where the consumers live. So the supply chain advantages of vertical farming are at least as important as the production advantages. We are changing food miles into food steps. We are changing the concept of harvesting 4 to 5 days prior to the consumption moment to harvesting half a day before consumption. That has a huge effect on both taste and nutrient value. So we are able to harvest on the right moment, on the right quantity. This is the first time with vertical farming we will be able in agriculture to really make supply meet demand. So we can do this without hardly any waste. And we can do this really small scale or big scale. So we can do this no matter what climate, no matter what season, no matter day or night, and no matter what location. And it could look like this. It could be a nice looking building somewhere in desert. Or it could be exactly the same building at the polar circle. Or it could be the same building somewhere in the center of a city in India. There is a fifth misconception that says food must be grown large scale. That's so much connected with the traditional supply chain. We are used to compete each other with cost leadership instead of quality. In this new system of vertical farming, we will be able to produce qualities that we have never tasted before. And that will be so much added value that we are able to use smaller scale units that totally are adapted to the market that we are going to supply. It could be on the 24th floor, but it could be really small scale, like produce, as we have seen today, your fresh vegetables right in the fresh department of your supermarket, or even smaller in a restaurant, or at home. The smallest production unit that we have made so far is the size of a microwave, and then we have one size of a walk-in closet, and then it becomes bigger and bigger. So in the end we will be able to grow our tomatoes in our kitchen drawer. Well, another misconception is that vertical farming would be just another way of growing. That's not true. It's much more than another way of growing. It actually combines two great things at once. It's a great way of producing, much better than we were able to, and it's a great new supply chain. And it's that unique combination that makes vertical farming so challenging. And maybe the most important one is this one. It's almost zero waste. And that's something, although transportations might not be that expensive, it's ridiculous to lose 50% of the production that we are making on this planet. So the last misconception, it will take years before this is going to happen. I really can't find a reason why. Technically, we are able to do it today. If you look at the performance of the LED systems and at our performance, you can see that today the next step will be within 18 months that the prices of the LED systems will drop with 50%. That's at least what, for instance, Philips company has mentioned. And the next 80 months, these prices will drop again with 50%. And in the same period of 3 years, the performance of LED systems will double. And then we are just toddlers at PlantLab. We are able to optimize our performance with another 50% easily within the next 3 years. So if you look at some figures that you could compare with what Jean just mentioned, today, if we are growing tomatoes, and we have been doing that for the last 1.5 years, and we're still learning, but today we use 23 kilowatt hours totally for the whole system for 1 kilogram of tomatoes. And within the steps that I predict for the next 3 years, we will move to 8 kilowatt per kilogram within the next 3 years. That's a reduction of 67% in costs. And if you take the whole system, and it's just a ballpark calculation that we use for this, with depreciation, interest, labor costs, supplies, and of course electricity and labor, today a kilogram tomatoes would be about $7. But within 3 years, it will be less than $3. And just to put that into pounds, it would be $1.26 per pound. And just to have a benchmark, is this a lot? I went to a supermarket yesterday here in Washington, and they have the guts to ask $5 for a pound, meaning that if retail was purchasing it for the price of $1.26, they are still able to make a fair profit as they are used to. We were not allowed to talk today about why are we here. So if we're not allowed to start with this, I would like to end with this. We are here because the current supply chain is not good enough. It's good enough for some products, but it's not good enough for fresh. And we have really a problem with this crowded planet growing from 7 to 9 billion people. So I really feel it as we are here as our challenge to do this much, much better. I know that we all want to be part of a solution instead of a problem. And we want to come up with plans and ideas instead of excuses. And we want to make something happen instead of waiting for something to happen. And that's why I think that vertical farming is such a great idea. We have to feed the world in a much, much smarter way. Thank you very much.
Thanks a lot for that nice ending for the last talk of today before the panel. Other questions to the speaker?
Fascinating stuff. Have you put your inventive and creative minds to the problem of grains?
Yes, but if we look at corn, potatoes, soybean, commodities, these are not the crops that are economically feasible to produce. But on the other hand, if you want to improve the breeding processes or the propagating processes, these systems are ideal. So we have to start where it's feasible. Don't make the problem bigger than it is already. So we start in the top of this pyramid with breeding young plants and of course those crops that are feasible today. And then the coming decades, we will move slowly downwards in this huge pyramid.
I didn't quite understand the one slide where you showed plants growing under red and blue LEDs. You were talking about very low light levels, light compensate.
But that depends on the crop. So we use very little light if you compare this to greenhouses. Actually, the more we understand plants, the less light we use for getting the same performance. So sometimes we are at 70 micromoles or 100 micromoles, and there are crops, and those of course are most of the time shadow crops, that we can grow hardly using any lights, 10, 20, 25 micromoles. So there is not a standard in our system. We do the things opposite from horticulture. Horticulture builds a greenhouse and then learns by doing. We do it in the opposite direction. We first make an idea, then we make a recipe, and once we have done the recipe, we also have done the feasibility study, and we are 100% sure that it does work and that it does make sense also money-wise. So the light level is connected with the crop, as the whole recipe is connected with the crop and the specific targets for that crop.
Now, with your 10 different recipes for the basil, have you optimized, have you written enough for the software like linear programming models that will actually iteratively optimize, and even, I don't know if you have different pricing structures, whether it's daytime or nighttime use of energy, and but it seems to me that the next step, if you haven't done it already, is to have a linear programming model that optimizes for those recipes so it would home into the maximized production. And even later, when you start selling it to the consumer, if you get the consumer give you a feedback loop on taste.
Yeah.
Is that where you are you there yet, or is
Yes,
that
we
where
are
you're going?
there, but it's more complex actually. So it's not just about yield. In Holland they tell us that we should eat 200 grams of vegetables and fruits on a day. Nobody does except the cow does, but we don't. But it's based on nothing. It's based on the assumption that in those 200 grams there should be enough. I'm sure that we are able with vertical farming to put more than that in 20 or 30 grams. So within the next 10 years, we are not talking just about yield or just about investment costs. We are talking about added value, about nutrient value, about personalized food. This is a total new generation. This is very exciting. This is going to be the most sexy area there you can be.